All right, we're going to do some more examples of solving for the missing angle when we're looking at angles between 0 and 360 degrees. So that's the first period of the sine graph, and the cosine graph is our focus today. So I'm going to go over two questions that review what we talked about in our last video, and then two questions that are slightly more difficult. So the first one we're going to look at is cos theta is equal to negative 1 over 2. So if we look up in our triangles, we see that this triangle has a 1 and a 2 in it, and if we use the related acute angle of 60 degrees, then adjacent over hypotenuse will give us the right angle. So we need to identify when do we have a related acute angle of 60 degrees, and it has to be negative. So we have one answer over here and one answer down here, because those are the quadrants where cosine is negative, and we know that the related acute angle has to be 60 degrees. So our first answer is going to be between the positive x-axis and the terminal arm, 180 degrees minus 60 degrees, so that's 120 degrees. And our second answer is 180 degrees plus 60 degrees, because we have to go 180 degrees plus another 60 degrees, which gives us 240 degrees. So we have two answers. The first one is 120 degrees, the second answer is 240 degrees. So our second question, B in this example, again, 1 and root 2 are both members of this triangle here. So our related acute angle is going to be 45 degrees, because sine is the opposite over the hypotenuse, and it's a positive ratio in this example. So sine is positive in quadrant 1 and quadrant 2. So we know the related acute angle is 45 degrees in both of these cases. So our first answer is 45 degrees, because the related acute angle is the distance from the positive x-axis to the terminal arm. And then from the positive x-axis to our second terminal arm over here, we would get that that's 180 degrees minus 45 degrees. $135 degrees is our second answer. So we have 45 and 135. So our next example, this starts to look a little bit more like an equation. So what we want to do is isolate for cos theta by dividing both sides by 2, because on the left-hand side then, 2 divided by 2 gives us 1. And if we refer back to what we were doing earlier in this unit, we know that we would not have any restrictions, because dividing by 2 doesn't cause any issues for our variables. So that's a good thing to always make note of from now on, which then simplifies that cos theta is equal to 1 over 2, which is very similar to part A above, except we don't have a negative sign. So we're going to use 60 degrees as our related acute angle again, but this time we need to put our terminal arms in the positive cosine quadrants as opposed to the negative. So again, in part A, we put the terminal arms over here because the ratio is negative. Down here, we have the ratios being positive, so the terminal arms are going to be on this side. So that tells us that theta 1 is going to be 60 degrees, and theta 2 is going to be 360 degrees. Subtract 60 degrees, 300 degrees. So we have our two answers. From the positive x-axis to our first terminal arm, 60 degrees, positive x-axis to our second terminal arm, 300 degrees. And I just want to link that back to the shape of the cosine graph. So it starts up at a height of 1, goes down to negative 1, and back up to 1 again, where this is about 360 degrees. Then we would have about 180 there, 90, 270, a height of 1, a height of negative 1. Now, cosine theta is at a height of a half right here, which would make sense that that's 60 degrees. My graph is not drawn to scale. And then all the way over here at 300 degrees. So there's 2 times that the graph is at a height of 1/2. And then our final example, really doesn't look like a ratio that we can solve for yet, but we're going to isolate for sine theta by first subtracting root 3 on both sides and then dividing both sides by 2. After you've practiced a few of these, you're more than welcome to do those 2 steps in 1 step if you'd like. Now, root 3 over 2 is indeed from one of our special triangles, and we know that it again has to be 60 degrees because it's opposite over hypotenuse in the sine ratio. So we're going to use a related acute angle of 60 degrees. Sine is negative here and here, so we have 60 degrees, 60 degrees, and we know that it's negative from this negative sign over here. So, from the positive x-axis to our first solution, that would be 180 degrees plus 60 degrees, giving us 240 degrees. And then our second answer is 360 degrees, subtract 60 degrees, which is going to give us, not 60, 300 degrees. Sorry about that. So we have, again, from our positive x-axis all the way around to the third quadrant, to our first terminal arm, 240 degrees, and the positive x-axis to the second terminal arm, 300 degrees as our 2 solutions, which again makes sense if we relate that to our sine graph, because my very quick sketch here would show that we would have a negative root 3 over 2 at 2 locations, and it does make sense that this would be 240 degrees, and this would be about 300 degrees on our x-axis if we were to sketch that. So those graphs are just to kind of make a connection between the graph of the sine function, the graph of the cosine function, and relate it back to solving. Thank you.